Feed your fish by allowing your tank to make food for the fish. That's it in a nutshell. We want maximum diversity and maximum nutrition. Well, hello. Come right on in. You're at Father Fish. Our goal is to maximize the diversity and maximize the nutritional component that's needed in order to support that diversity. Do you get that? We want maximum diversity and maximum nutrition. Now, how do you do that? I'll tell you how you don't do it. You don't do it by dumping a can of food in the tank. You don't do it by overfeeding your fish, because your goal is to feed every animal and plant that is in that cycle. And there are literally thousands, tens of thousands of individual living creatures in that life cycle, in that maximized diversity system. So, back to the question, how do you provide food for that wide range of critters? We did a lot of research on this. By we, I mean me and a couple of other people who are on Discord who are researchers, bona fide researchers. We discovered research that was done on the Orinoco. They studied the impact of leaves, that's the leaves from trees, on the food cycle in a given range on that river. They discovered that leaves, the leaves of trees, were and are the primary food source for the entire ecosystem. Whoa! Whoa! Well, it doesn't mean that peacock bass eat leaves. It doesn't even mean that leaves feed the prey of peacock bass. It means that the microculture, which includes all of the microfauna, the microflora and the macroflora, that's plants and animals, the macrofauna, all of those, the bacteria, of which there are thousands of species, the arachnia, which I don't know what that is, but it's a bigger class of stuff than bacteria, the fungus, of which there are hundreds to thousands of different species. All of these feed on, in one way or another, the leaves of trees. In the process, they break it down to the point where it becomes nutritionally available to the plants. So the plants then take it up. And what happens to the plants? Some of them get eaten by fish. And some of those fish eating the plants get eaten by other fish. So there you have just a very simple way to explain the cycle. You have to feed every single animal in the cycle, and there are millions. It's not just a matter of feeding the fish. First of all, we're dealing with aquariums, so that's pretty small compared to a river or a pond or a lake. So that means to do this system, we've got to have pretty small critters in the tank. Now, the microscopic stuff is not a problem. That's already tiny. The question is, what do we do about macroinvertebrates, snails, shrimp, and fish, and plants? Obviously, this works best and easiest and most effectively with smaller fish. Fish that are 2 inches or smaller. A 2-inch fish is not going to have any trouble surviving on microfauna, algae, because a couple of the things that the cycle produces in pretty good quantity are fairy shrimp, daphnia, scuds. Macrofauna, worms that are big enough that an angelfish can eat 2 or 3 or 4 a day and have adequate nutrition. And we can raise that level in an average 20-gallon tank. So you can have fish as big as angelfish that will be able to be part of the cycle, part of the balance. Obviously, if we're going to put a fish in that tank that depends on being able to eat other fish, then we better have a righteous population of other fish available for it. Now we can put them in, but by doing that, we're breaking into the cycle at a given point rather than allowing that cycle to be a cycle. We're short-circuiting it. That's the only way they can get them. That's not part of the cycle, and they're not part of the cycle. They're living on top of the cycle or instead of the cycle, except they're pooping and peeing and they're messing around and they're doing other stuff in there which is affecting the cycle. We can't do big fish that require special food that cannot be provided by the cycle. This is the important part of this whole thing. The tank functions in such a way as to provide nutrients for every single animal and plant that's living in it. Nobody gets left out. Now, clearly, if you have 5,000 piranhas, it ain't going to work. So you got to be reasonable about the number of fish that are in there. But you can have schools of little fish. You can have schools of cardinals, schools of tetras, dozens and dozens of shrimp, even more, hundreds of shrimp. You can have an awful lot of stuff in there, provided you have a lot of plants, and provided you're seeding it with a wide diversity of microfauna as well as macrofauna, and the nutrition they require in the form of leaves, bark, other waste material that comes off the trees or other plants. If the leaf of a plant in the tank dies, what do? Here's the problem. The fellow I was talking about earlier said you have to take it out. But if you do, you're denying it as food for a whole rank of animals that are depending on it being there. The more of this food you put in a way that gets assimilated naturally. That's important. You're not dumping a can of food in. You're putting food in a way that allows it to be taken up and used naturally and put through a cycle. The more of that you're able to do, the stronger and more vibrant and richer and healthier that cycle gets. It maximizes resources. That's the nature of the nature system. Feed your fish by allowing your tank to make food for the fish. That's it in a nutshell. Nature is not an impoverished system. It's not based on that. It's been around for millions, hundreds of millions of years. It is rich in diversity, rich in nutrient, rich in biological activity. So can your aquarium be just that. That's how you feed your fish, by feeding everything in the tank. And your fish will thrive on what is being fed, what is being created, It all becomes a cycle of life. The fish eat something smaller, which eats something smaller, which eats something smaller, down to the molecular level. I mean, it's literally true. It's a balance. And you can maintain that balance simply by providing a level of nutrition that can be absorbed and assimilated by a wide range of fauna, microfauna and microflora. Primarily microfauna, but also macrofauna, shrimp, snails, and the like.